Hello everyone. So in this video, we'll solve this logarithm equation. So in order to solve this equation, we'll have to isolate the variable in the equation, which is x. Now x is present here in two log terms. So we'll have to find a way to bring this x out of the log. Now both of these log terms are on the left side of the equation. They are being added and they have the same base. So that means I can use the product law of log. So I'll write the product law on the board. So the product law states that log of y to the base a plus log of z to the base a can be combined into a single log term. So it becomes log of yz and the base stays the same. So we'll do the same step for these two log terms because they have the same base. So we get log of x times x plus 2 to the base 2 equals 3. We have to get rid of this log with this term because this term has the variable x in it and we have to isolate the variable x. So we can do that by converting this log form to exponential form. There is no log term on the right side of the equation, so we can easily convert this log equation into an exponential equation. So the rule for that is, so log of m to the base n, if this is equal to say y, then we can convert this log equation into an exponential equation by making the base of the log the base of the exponential term. So we get m equals n to the power y. So the base of the log becomes the base of the exponential term. So we can do the same step here. So the 2 here, the base of the log becomes the base of the exponential term. So we get x times x plus 2 equals 2 to the power 3. So now there is no log in this equation. So this is just a regular polynomial equation. So we have to solve this polynomial equation. So the first step is to distribute the x into the parentheses on the left side. So we get x squared plus 2x. And on the right side, we can evaluate 2 to the power 3, which is equal to 8. Now we can see that this is a quadratic equation and it's a trinomial because none of these three terms are like terms. So we should set it equal to 0 and solve the equation. So for that we should subtract 8 from both sides. So the 8's on the right side cancel each other out. So we get x squared plus 2x minus 8 equals 0. Now this equation is a simple trinomial because the coefficient of the x squared term is 1. So we can use the sum and product rule to solve this equation. So we have to find two numbers whose sum is equal to 2 and the product is equal to negative 8. So the sum number is the coefficient of the x term and the product number is the number term in the trinomial. We have to think of two numbers that satisfy these two conditions. So the first pair of numbers that comes to my mind is negative 1 and 8. So we focus on the product number. So, but we cannot get a sum of 2 from negative 1 and 8. So this pair is out. So the second pair that comes to my mind is negative 2 and 4. Now negative 2 plus 4 is equal to positive 2. So negative 2 and negative 2 times 4 is equal to negative 8. So that means the two numbers we are looking for are negative 2 and 4. Now we can write this equation in factored form. So we get x minus 2 in the first parentheses times x plus 4 equals 0. We get two cases. So to solve for x, so the first case is x minus 2 equals 0, and the other case is x plus 4 equals 0. So for the first case, we have to add 2 to both sides. So the 2's on the left side cancel each other out. So we get x equals 2. And for the other one, we subtract 4 from both sides. So the 4's on the left side cancel each other out. And we are left with x equals. So these are the two solutions we get for this logarithm equation. Now we have to check if any of these two values is an extraneous root. So extraneous root is a root that makes any of the log term in the given equation invalid. So we know that log doesn't exist for 0 and a negative number. So we have to do the check for both of these values. So let's start with our check. So we'll start with the first x value. So x equals 2. So we sub in x as 2 in the given equation. So log of 2 to the base 2 plus log of 2 plus 2 to the base 2 equals 3. Now we have to check if the left side becomes equal to the right side. So log of 2 to the base 2 is equal to 1 because the term and the base are the same. And then we get log of 4 to the base 2 equals 3. Now we know that we can change 4 into a power of 2. So 4 can be written as 2 squared. We can use the power law of log and bring this exponent to the front as a coefficient. So we get 2 log of 2 to the base 2 equals 3. Now log of 2 to the base 2 is equal to 1 because the term and the base are equal to each other. So we get 1 plus 2. So 2 times 1 is 2 equals 3. And then 3 equals 3. So that means our first solution x equals 2 is a valid root. And now we have to do the check for the second solution x equals negative 4. So we'll sub in x as negative 4 in the given equation. So we get log of negative 4 to the base 2 plus log of negative 4 plus 2 to the base 2 equals 3. Now, as I mentioned earlier, log doesn't exist for a negative number, so this term here becomes undefined. So that means the second solution, x equals negative 4, is an invalid solution or an extraneous root. So the only valid answer here is x equals 2. So this should be the final answer for this log equation. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.